Again, another optional question. And again, doing optional questions will give you better options in life. All right, so it's an equation, and when you solve for x, and you got an equation over here to solve. All right, so what I would do over here is kind of look for some commonalities between it. So let's go through that. And the first thing I'll notice, and I'll write this down for you, 2 to the x, and that's minus 3 to the x. Looks like a difficult problem to deal with. Well, what I notice immediately is I notice that 6 to the x is actually 3 times 2 to the x. Minus, and 9 is 3 times 3 to the x. Let's keep writing this over. And what I'm going to do is I'm going to factor out 3 to the x is common between the two terms. And you left off with 2 to the x minus 3 to the x. All right, to make it a little bit simpler, because I don't feel like rewriting this over and over again, I'm just going to say a is equal to, it's going to make it easier for me, just in the writing department, and b is equal to 3 to the x. So what do you get? You would get a minus b equals, let's be careful here, b, and then a minus b. All right, I'm going to square both sides. You get a minus b squared is equal to b, a minus b. I'm going to use zero product rule. You get a minus b squared minus b, a minus b equals 0. Factor out a minus b. We're left off with, well, you left off with a minus b equals 0. So you get a minus b times a minus 2b equals 0. All right, so one thing I know about this, just using the zero product rule, I know that a equals b is one possibility. The other possibility is a equals 2b. I think the a equal b is easier for me to deal with. And what's that going to be? Well, what's a? If you can't remember, we have it written down, right? It's 2 to the x. And what's b? Well, if you can't remember, look it up. It's 3 to the x. Let's write the other one down. That's 2 to the x. And that would be 2 times 3 to the x. Again, I think this one's easier to deal with. Let me go through that. And I would probably take logs of both sides. Although it's an obvious answer, but let's say it wasn't. You take logs of both sides. What do you get? X ln 2 equals x ln 3. Let's see, solve for x, right? And what would you get? X, and I'm going to subtract x ln 3 from both sides. You get ln 2 minus ln 3, and that would be 0. So x would equal 0 over ln 2 minus ln 3, which of course is 0. So one of my solutions is x equals 0. That's a pretty simple one. All right, we'll check it later. I want to do this one over here, though. A little more complicated. And let's go through that now. So what does it mean? 2 to the x is equal to 2 times 3 to the x. I'm going to divide both sides by 2. So you get 2, x minus 1 equals 3 to the x. I would take logs of both sides. What do you get? X minus 1, the natural log of 2, equals x, the natural log of 3. I'm going to simplify this. X ln 2 minus ln 2 equals x ln 3. Let's see, x ln 2 minus x ln 3 equals ln 2. I'm going to factor out an x, and you get x ln 2 minus ln 3 equals ln 2, or x equals the natural log of 2 over ln 2 minus ln 3. All right, so I found two solutions, and let me just repeat that. The first solution I found was this one over here, relatively simple. And the other solution I found, I'll put a box in that now, is this solution over here. Whoops, I'll put a box on it first. All right, I'll color it in too. All right, so certainly checking those solutions really isn't that bad. Certainly, I'm going to say 0 is pretty easy to check, and you can do that pretty rapidly. So let's go through that. Let's go back to black ink. X equals 0, the check. And what do you give there? Well, 2 to the 0 is 1. 3 to the 0 is 1. 6 to the 0 is 1. And 9 to the 0 is 1. So you get 0 equals the root of 0. Certainly makes sense. Now, granted, you might find the other one to be more difficult to check, but you could still check it. I mean, you could still write that down and check it, all right? What I did instead, though, instead of going through the numerical workers, I just graphed out the two problems. And I'll tell you what I've graphed out over here. And there's two graphs I put down for you. One is going to be y equals 2 to the x minus 3 to the x. And the other graph I put down is y equals, well, that was the root of 6 to the x minus 9 to the x. Let me just go back up here and show what I'm talking about. I graph this, and I'm graphing this, each side. And I'm wondering, where do they intersect? All right, now what am I claiming? They intersect at two places. The one place they intersect is at the point where x is 0. The other one is at the point where x is equal to the natural log of 2 divided by the natural log of 2 minus the natural log of 3. All right, so we have two different answers. All right, so let's go through this, and let's just talk one thing at a time. All right, let's talk about the blue curve first. The blue curve is the root problem. All right. Oops, sorry about that. I can get the highlighter out. The blue curve is this one over here. All right. So I'm looking at it, and I want to do the other curve now. I want to do the green one. The green curve is this curve over here. All right. There's two places they intersect. Let me highlight those for you. Here and here. Well, this is clearly where x is equal to 0. We found that already. And this one over here, and I did plot the point, is the natural log of 2 over the natural log of 2 minus the natural log of 3. All right. By the way, they can be written differently, by the way. There's some people don't like them write that way. I like natural log because it's typical for us. All right. That's about it. Again, I want to remind you, if you have any questions, my name is Ron Bannon, and my email address is Bannon, B as in boy, the @ symbol, NNON.US. Again, these are optional questions. I think they're good questions. I think they're difficult questions. And I think it's appropriate for what we're learning here. Thank you.